Hello everyone, this is Lecture Pro. Andrzej Michalczyk speaking. We're beginning a case study, the first case study, engineering case study about the nuclear explosion and the nuclear disaster at the Chernobyl nuclear power plant, which happened on the 26th of April 1986. What we will do today, I have divided into several sections, nine sections to be precise. I will cover this not in one long video, but in several smaller ones, shorter episodes. So here is the first one. The first thing we will have a look at is the design flaws, the errors or mistakes made during the designing of the nuclear power plant in Chernobyl, which led to the disaster. So design flaws. The first design flaw is connected strictly with the reactor itself. It was built, constructed, or designed in such a way which made it highly unstable when operating at low power. This is strictly connected with something that is called a positive void coefficient. This scientific name may be difficult to understand for non-specialists. I'm not a scientist myself. However, it simply means that the reactor used in Chernobyl, the RBMK type reactor, worked like this. The more power it used, when the power went up, it increased reactivity. Reactivity is the number of nuclear reactions happening inside the reactor. So simply, the more power the reactor used, the higher number the nuclear reactions happened in the reactor core, generating more electricity. Generally speaking, this is a good, let's say, a good rule, a good solution for a reactor. We want to have more power. However, when operating at low power, the machine, this reactor, became highly unstable, and its behavior could be unpredictable. So there was a mistake in the design of that reactor itself. Another major problem, major means very big, very high, very important. Another major problem with the design of the reactor was that the control rods were also defective. They had inherent flaws in their design. Inherent means that something is part of a thing's nature. Something is by nature, no good or bad. Yes, inherent. So they were inherently poorly designed. Basically speaking, control rods are elements which, as the name says, control the number of reactions happening in the reactor. If you want to have more reactions and generate more power, you pull out the control rods. If you want to decrease the power, you push or press the control rods back. This is how a reactor usually works. However, the construction of the control rods was, as I said, contained a huge error. The control rods were made of boron. This is an element. It works in such a way that it slows down the number of reactions happening in the reactor. But they were tipped with graphite. The tips of the control rods used in that reactor were made with graphite, and graphite is a moderator. A moderator is an element which accelerates or speeds up the reactions in the reactor. So simply, this design contained a very huge mistake. I will explain why later. And another major design problem with that reactor was the poor ratio of coolant to fuel. So in other words, there was not enough coolant water to cool the reactor in case anything bad happened or started happening. They did not have enough water reserves in case of an emergency. So again, this is serious design flaw or a design oversight. An oversight, by the way, is something that we forgot to take into account, forgot to think about. Okay, so this was the first section. Basically speaking, we've just covered the design flaws, which contributed to, which led to the disaster. The second issue are production flaws, and by that I mean the flaws or mistakes made during the production or construction of the nuclear power plant itself. Uh, Basically speaking, it all comes down to using improper materials, improper construction materials during the construction. Uh, any kind of object, power plant, nuclear or regular, has to be built, constructed using proper materials, which meet specific norms and requirements. The same with the nuclear reactor building. What the managers and directors of that project, of the construction project, did, however, they deliberately and knowingly ignored those norms. For example, they were supposed to build a cover for the reactor, like a huge something that would cover the reactor, yes? And they were supposed to use non-combustible materials to do that. Non-combustible means that something cannot burn easily. So they were supposed to use non-combustible materials to build that cap for the reactor to cover it. What they did, they used combustible materials. So they used materials which could easily burn or could not resist high temperatures. In case of an emergency, this is always a potentially bad situation. But they deliberately ignored that and they used low quality, low grade materials. This was a mistake in the decision making process, which shows that the people who were building that were not thinking rationally for a couple of reasons, mainly because they were under a lot of pressure, outside or external pressure from the supervisors of the project, political supervisors, the politicians. Uh, the politicians wanted them to finish the project quickly, preferably even before the deadlines. If they did, if the managers did finish that project before the deadlines, then they would receive huge bonuses. So financial incentives, if you want. Simply speaking, they would receive extra money, and that was one of the other things motivating them to work faster, but also at the same time ignoring some safety procedures and also making mistakes, making wrong decisions regarding the choice of materials. So this basically, let's say, covers the second point, why the Chernobyl disaster happened, designs during the construction process, the construction phase. Okay, number three issue which we'll cover in this episode is connected with operational errors. Uh, mm, Basically speaking, these are mistakes during the operation, working with the reactor itself. Uh, they were performing a test. They wanted to test how well the reactor would work if they turned off the main power, the main turbines. Uh, and they wanted to test how long the reactor would work on its own before the auxiliary or secondary diesel and diesel generators would start working to keep up the work of the reactor itself. They wanted to test that possibility. Uh, but they were in a hurry. They rushed this test. They wanted to do it fast, ignoring safety procedures, ignoring even emergency systems, alarms. They deliberately ignored a lot of things. Incidentally, they also did not know about the instability of the reactor itself, but we will cover this in another point. So basically speaking, they were rushing the test. They wanted to do it quickly, ignoring the safety procedures, which is never a good way of how to run a complex piece of technology. Uh, Also, the emergency systems have been deactivated for the test, for the duration of the test. So while they were testing, they started receiving several alarms, which was a standard reaction of the monitoring system, emergency systems. They started telling them that something is wrong, something is not going the right way, and what they did, they ignored that. Well, basically speaking, if a complex machine is telling you, hey, something is wrong, you should check this out, you should monitor this, we should react to that. Yes, but they deliberately switched off the alarm systems because they found that to be irritating, or to be specific, the supervising engineer who was monitoring that test, Dyatlov, he made the decision to switch off the alarms because he found them to be irritating. Also, the procedures for the operational procedures for monitoring the work of the reactor, they were not specified enough. Okay, they had some manuals, they had some instructions how to work with the reactor. However, those procedures were not specified. They did not cover all possibilities, and they also did not cover how to work, how to operate a reactor in some unforeseen or critical situations. So procedures were not complete, and what was even more interesting, they deliberately ignored some of the recommendations written in those existing procedures. So as you see, again, they've made quite a lot of mistakes, even during the operation of the reactor itself. So this is not a good way of running an operation like that, working with a complex piece of technology. So that covers the operational errors. Right, I will stop here. However, this is only the first part of a series of short videos, so stay tuned, because I will add more videos about analyzing what happened and how things happened, including the crisis management of the disaster itself, how they dealt with the effects, with the aftermath of the explosion. So that's not all. There will be a couple of more videos about this. Please stay with me, watch, listen, leave comments, be sure to subscribe and put a like, and see you soon.